Hey everybody, in this video we are going to be continuing our discussion on coordination chemistry, and we're going to talk specifically about naming coordination compounds and complex ions in this video. So if I were doing this out there, meaning watching this video, what I would do is I would pause this video right now and kind of write down these rules about naming coordination compounds. And then a little bit later on, we're going to actually go through some sample problems, and then I would use these rules to name and come up with formulas for the sample problems. It's hard to explain or to spend time explaining rules like this without actually doing the sample problems. That said, I will go over a little bit of these rules now in hopes that some of it will stick in your head when we go over the names. But here's what happens. In a coordination compound, you always name the positive ion or the cation first. And this is true anytime we're naming. So if we had a compound like sodium chloride, the sodium, the cation, is named first, and then we name chloride. So what's going to change is that either the cation is going to be this big, long, like junky thing that we've talked about, and then it's going to be chloride or bromide or nitrate or something silly at the end. Or it's going to be that this we have sodium or potassium or some simple metal, and then this thing is going to end up being a big, long thing. But the idea is that if we know how to name ionic compounds, we should have some rudimentary understanding about how to name coordination compounds. Okay, one of the things that ends up happening is that you always name in a coordination compound. Let's say you have something like this. Okay, this is an ion, a complex ion. You're always going to name the ligands first, and they always get named alphabetically, which is very strange. Okay, so so you have to figure out all the different ligands that are in there. In this case, there's just one. This is the amine ligand. So this is, you're not going to have to worry about that. But then you name the metal ion. So this is going to be named amine, and then ruthenium is going to be named at the end. If you have a ligand that is a negatively charged, it usually ends in O. Okay, so this is a neutral, so that's why it's not amino. Okay, it's just amine. Okay, and then if it's a neutral ligand, like this is a neutral ligand, typically we would just name its name. We would just give it whatever its name is if it were a covalent compound. The exception is water, which we call aqua, and then NH3. Again, here's NH3 that we call amine, and then CO, which is normally carbon monoxide, but we call that carbonyl. Okay, and so just like we do in covalent compounds, if there is more than one of the ligand, we would use the prefixes di for 2, tri for 3, tetra for 4, penta, hexa on down the lines. But the prefixes don't get put into when we're dealing with alphabet. We only look at the ligand for alphabet. Okay. If for some reason the ligand that we have has a prefix in it, we use these weird, funny versions of those. So like ethylene diamine has di in it. So if we have 2 ethylene diamines in it, we're going to say bis ethylene diamine. So it's kind of strange. Okay, and so we're going to have to figure out what the Roman numeral or the oxidation number of the metal is. If it's a transition metal, remember transition metals can have all sorts of different oxidation numbers, so we have to make sure we know that, and that's indicated in Roman numerals. And if the complex ion is the anion part, is the negative part, the end, then it ends in 8. And so if there's a Roman numeral, then that follows that suffix. So what I have here also is just common names of ligands in coordination compounds. So, you know, bromo, chloro, cyano, hydroxo, oxo. So there's all sorts of different things. And again, it's better if you see examples of this, although it's good to have a list of all of these different elements and ligands so that we can figure out the names. Now, the funny thing is going to be the names of metals if they're part of the anion, because remember, the anion has to end in the ending 8, right? This rule down here, right? If it's an anion, it ends in 8. So if a metal is part of that anion, part of the negatively charged thing, it's going to end in 8. So we have aluminate, chrome 8, cobalt 8. Okay, and then the things like the things that are Greek, okay, copper, the symbol for copper is Cu. That comes from the Greek cuprum. So we use the Greek cuprate in order to talk about copper. Okay, and that's true for tin. Tin comes from the Latin stannum. Okay, so we use stannate. Okay, silver, Ag, that's argentum, so it's argentate. Lead is plumbate from plumbum. Iron is ferrum, ferrate. So it's good to kind of have these at the ready when we do this. Okay, so let's try to name some of these things. Okay, so I have some sample problems and it says, what are the names of these things? So the first thing that we should do when we try to name these things, and if you want to, you can pause the video here and you can try to come up with the names if you can. If not, let me do one and you can try the next one maybe. So the first thing that you should do is you should be able to separate this into the two parts. Okay, just like an ionic compound. Okay, and so this ionic compound is chloride. So the ending of this is going to be chloride. Okay, the challenge of this is going to be naming this complex ion. Okay, and so again, this is an ionic compound, but you have this complex. You have the complex ion here that's going to be the challenge to name, and it's really this. So this one is going to start with potassium, and then we're going to name the complex ion afterwards. Okay, so it's really naming these complex ions that's going to be the challenge for these. Okay, so when we have a complex ion, again, we name them alphabetically. So we have chloro and amine. Okay, so amine comes first, and I don't even know where to start. So I guess I'm gonna start here. And how many amines are there? There's 4. So that's going to be tetra amine. And then how many chlorines are there? Di 2. So that's dichloro. If I can spell chloro right. Okay, tetraamine dichloro, because again we have to do it in alphabetical order. Dichloro, and CO is cobalt. Okay, and it's not the anion, so it's not cobalt 8. It's just cobalt because it's the first part of it. And now we need the oxidation state of this. So again, this is where the previous video comes into play. So we have CONH3 4Cl2. Okay, and then we have Cl. So this is a -1 charge. So that means that this is a +1 charge. So we have to get somehow this thing to add it up to a +1 charge. So this is 2 minus because there's 2 of these. This is neutral. So the only way to get 2 minus up to 1 plus is that this is 3 plus. So this is going to be cobalt and then 3. There's no space between the Roman numeral and the metal. Okay, but these two they're separate words. So the name of this is tetraamine dichlorocobalt 3 chloride. Okay, right? And so this is where you need some practice, because it's like, I would say that this falls in the category of not necessarily difficult. What it is just a little bit of a like just a practice makes perfect scenario. Okay, so the second one here is potassium something or other. Okay, so again, we were able to split this here, and now we look at this thing. Okay, so again, we name the ligands first. So CN, I'm going to even go back and look. Okay, CN is cyano. Okay, so this is, let's see, how many CNs are there? So it's hexacyano. And then iron, this is part of the negative charge, right? This is the plus, the positive is always the first one. This is the negative one. So now this, because it's the negative side, this we do have to use the 8. So this is ferrate. And then we have to know what the oxidation state of that is. So again, potassium, when we look at this, potassium is a 1 plus. So that means that iron, that is this whole thing is a 1 minus. Now, cyanide from our list, if we look, cyanide is a minus charge. So this over here is 6 minus, there's 6 of them. So the only way to get iron, the only way that this can equal 1 minus is if the iron itself is a 5 plus. Okay, so that's going to add up. So this is hexocyanoferrate, and then we will put that in parentheses with a Roman numeral V for 5. Okay, so that's potassium hexacyanoferrate 5. That's the name of that compound. Okay, so now we can go the other way. What if we have a name and we want to come up with the formula? Okay, well, this, in my opinion, is a little bit easier, except that we have to make sure that we make the correct number of each of the ions so that it cancels each other out. So, pentaamine chlorocobalt 2. So pentaamine chlorocobalt 2. So what I'm going to do is I'm going to actually start, or sorry, that's 3, not 2. I'm going to do this backwards. I'm going to start here with cobalt. So this is CO. And then pentaamine, that's NH3. And then penta is 5. And then chloro is Cl, and then because there's no prefix here, there's just one of them. And so that is the complex ion. But we need to know what the charge is on the complex ion so that we can cancel it out with the right number of chlorides. So cobalt here is a 3 plus. This is 0, and this is 1 minus. So the overall charge on this is a 2 plus charge. So that means that when we do this, and now it goes back to what we learned when we did ionic charges, ionic compounds, is that, well, we have a 2 plus, so that means when we make this, we need 2 Cl's in order to cancel that out. So the formula for that one is going to be CO NH3 5 Cl bracket and then Cl2. That is the formula of that coordination compound. Okay, so now we're going to do this guy. Dichlorobis ethylene diamine platinum 4 nitrate. Okay, so again, we know that nitrate is NO3, and that has a negative charge. So that's what we're going to use to cancel out the charge on the complex ion. So again, I'm going to go backwards. Okay, I'm going to start with platinum. So there's platinum. And then dichloro, Cl. There's 2 of those. And now look, bis ethylene diamine. I'm going to show you something here. This is how I'm going to know that you've listen to the video. The abbreviation for ethylene diamine is EN. You can just write EN, and that's ethylene diamine. That's pretty cool, okay? And that way you don't need to. That's one of those bidentate ligands. And there's 2 of them. It says bis, so that's going to be 2, okay? So now, again, that's the whole complex ion. And now we need to figure out what the charge on it is. So if platinum is a 4 plus, each chloride is a minus, so that's 2 minus, and ethylene diamine is a compound that's 0. So the overall charge on this is going to be 2 plus. So that means that we need 2 of these nitrates. So just like we would if we were making an ionic compound, we're going to put this in parentheses, and we're going to put a 2 here. So the formula for this is, let me write that up here so that everybody can see it clear and good. Okay. So the formula for this is going to be, after we get rid of all this extra junk that's around, is going to be platinum PT Cl2, then ethylene diamine En2, and then a parenthesis NO3, because that's nitrate, and there's 2 of those. So that's the formula for dichlorobis-ethylene diamine platinum 4 nitrate. Okay? So those are your sample problems, and we're going to, next video, we're going to talk a little bit about what we call isomers, and then that's about it. Okay? Have a great day, everybody.